This document is a pattern language in the Alexandrian sense, a vocabulary of named, interconnected solutions to recurring structural problems in Claude code development. Each pattern has a name, a problem statement that identifies the forces in tension, a solution that resolves them, a structural specification, and explicit relationships to other patterns. Patterns are not templates to copy. They are compressed insights about how to resolve tensions that will recur regardless of domain. A pattern applied without understanding the forces it resolves produces shallow imitation. A pattern understood produces genuine variants appropriate to their context. We've identified 42 patterns of agent architecture across 4 zones, from context and structural foundations to long-running applications. The key insight is that prompting is prose. Agent engineering is architecture. We achieve deterministic reliability through structural constraints. Taming the probabilistic machine involves applying an intent engineering harness to the probabilistic cloud. We force deterministic reliability out of creative models through deliberate intent engineering to avoid unreliable or brittle systems. Group 1. Structural foundations. The central tension in all agent system development is between the agent's need for rich, contextual, connected knowledge and the hard constraint of the context window. Every structural decision in a skill repository is a negotiation between completeness and loadability. These foundational patterns establish the terms of that negotiation for all patterns that follow. Pattern 1. Flat skill catalog. Keep all skills as peer directories at a single depth. The catalog is always discoverable with one listing operation. Adding a capability means adding one directory. The structure has no registry to maintain, no import wiring, no parent-child relationships to keep consistent. Pattern 2. Skill directory anatomy. Every skill is a directory. The directory contains exactly one required file, skill.md, and optional supporting files organized by type. The mandatory file is pure instruction. The optional files are pure reference, pure tooling, or pure example, never a mix. The agent reads the instruction file. It reads supporting files only when the instruction directs it to. Pattern 5. Knowledge workflow separation. Skills contain procedure. Knowledge directories contain facts. The skill instructs the agent to read from the knowledge directory when it needs reference material. The knowledge directory never instructs. Pattern 3. YAML front matter contract. Every skill, command, and agent definition opens with a YAML front matter block that contains exactly the fields the platform needs for routing, configuration, and lifecycle management. The front matter is the interface. Everything below it is the implementation. Pattern 4. Description as trigger criteria. Write the description as activation criteria, not workflow summary. The description answers, when should this skill be activated? Not, what does this skill do? The body answers the second question. Group 2. Context engineering patterns. The agent's world model is always incomplete. Context engineering patterns govern what information enters the context window, when it enters, and how it is structured so that the agent operates on ground truth rather than on stale training. The primary tension in this group is between completeness, the agent should know everything relevant, and loadability, what does not fit in the context window cannot be used. Pattern 6. 3-tier knowledge loading. Organize skill content into 3 tiers with different loading triggers. Tier 1, metadata, is always loaded. It is the routing signal. Tier 2, instructions, is loaded when the skill is activated. It is the operational guide. Tier 3, resources, is loaded on demand during execution. It is the deep reference. Pattern 7. Write to file, not context window. Large outputs are written to the file system immediately upon production. The context receives a summary only. Downstream steps read the file directly. Pattern 8. Source attributed state. Every value in a persistent state structure carries a source field identifying where it came from, the specific document, chapter, step, or observation that produced it. Conflicts are preserved as explicit unresolved entries rather than overwritten. Pattern 9. Cross-reference by name. Skills reference other skills by their registered name, not their file path. The name is the stable identifier. The path is a platform-specific detail resolved at load time. Group 1 defines the physical infrastructure, while Group 2 dictates the logistical flow, what enters the context window, when it loads, and how it is structured to prevent cognitive bloat. The context funnel in action shows how repository data is filtered. Tier 1 routing signals trigger the exact capability needed, and Tier 2 logic selectively pulls necessary Tier 3 facts into the context window, ensuring token efficiency. Synthesis. The rigid protects the fragile. The agent's dynamic logistical flow relies entirely on static physical infrastructure. Rigid discipline is needed to keep the context window lean, ensuring the agent's working memory is optimized for reasoning. That covers 9 structural pillars of agentic systems. We now focus on Group 3, harness engineering, the physical control system, and Group 4, intent engineering, the psychological guidance system. Other core tensions of agentic systems include autonomy versus safety, flexibility versus predictability, and speed versus correctness. Patterns in Groups 3 and 4 resolve these tensions by replacing abstract guidelines with hard structural limits. Group 3, harness engineering patterns. The harness is the control system that makes raw LLM capability into reliable work. The central tensions in this group are between autonomy, the agent acts without interruption, and safety, the agent is checked before consequential action, between flexibility, the agent adapts to context, and predictability, the system behaves consistently, and between speed, the agent proceeds, and correctness, the agent verifies. Pattern 10, explicit I/O contract. Every skill declares its I/O contract explicitly. Pre-reads are listed before the process begins. Output locations are specified in an output contract section, with exact file paths and formats. Pattern 11, pipeline composition. Each skill or command's terminal state explicitly names the next step to invoke. The pipeline is declared in the skill bodies, not in a separate orchestration layer. Each unit is a relay baton. It does its work and hands off. Pattern 12, checkpoint-gated autonomy. 2 complementary mechanisms address these forces and must be selected based on task length, model characteristics, and the desired trade-off between continuity and clean slate freshness. Pattern 13, bounded correction loop. 2 loop configurations address these different contexts. In both cases, the loop requires a maximum iteration count, a blind reevaluation rule, and a hard exit condition. The maximum iteration count and inflation assumptions differ significantly. Pattern 14, writer is not evaluator. Separate the writer from the evaluator structurally and calibrate the evaluator explicitly toward skepticism. Separation addresses the investment problem. Calibration addresses the generosity problem. Both are required. Pattern 15, deterministic creative split. Deterministic operations are handled by shell scripts. Creative and analytical operations are handled by the LLM. The division is enforced structurally. Deterministic operations appear only in bin/scripts, never in skill instruction bodies. Pattern 16, agent-facing error messages. All error output that may be consumed by an agent is rewritten to contain exactly 2 things: what went wrong, 1 sentence, and what to do next, 1 to 3 steps. All technical noise is stripped. Pattern 17, graceful degradation. Distinguish hard dependencies. The skill cannot function without them. Halt and explain. From soft dependencies. The skill can function at reduced capability without them. Degrade and document. Provide explicit fallback instructions for every soft dependency. Group 4, intent engineering patterns. Intent patterns govern what the agent is, what it will not do, and how it remains aligned with its purpose under pressure. The central tension in this group is between the agent's flexibility, adapting to context, and its fidelity, remaining aligned with intent. Flexibility without fidelity produces capable but unreliable behavior. Fidelity without flexibility produces brittle behavior that fails in unspecified contexts. These patterns resolve this tension through structure rather than repetition. Pattern 18, identity-first prompting. Every skill and agent definition opens with an explicit identity statement that names what this skill is and what it is not. The IS statement is affirmative and specific. The not statement closes the most likely colonization paths. Pattern 19, iron law. The most important behavioral constraints are stated as non-negotiable absolute rules in a visually distinct block. Each rule is stated in ALLCAPS. Each rule is immediately followed by explicit closures of the most likely rationalizations. Pattern 20, rationalization prevention table. For each iron law, enumerate the most likely justifications an agent would construct for violating it, and explicitly rebut each justification in a table. The table is generated from observed test failures. Each row represents an actual rationalization observed during skill development. Pattern 21, numbered hard rules. Collect all behavioral constraints into a dedicated, numbered ## rule section at the end of the skill. Number them. Write each as an imperative statement. This section functions as a self-verification checklist. The agent can scan it before marking completion. Pattern 22, Constitution as code. Encode project principles as a versioned, machine-checkable document using must-should normative language. Version it with semver, major for principal removal, minor for addition, patch for clarification. Run an analysis command that treats Constitution violations as always critical. When the Constitution changes, require explicit documentation of which templates and behaviors need updating. Pattern 23. Philosophy as code. Mechanically inject the core philosophical principles into every skill that should be governed by them via the preamble system. The philosophy is not read as a precursor. It is included as the opening context of every governed skill. The synthesis. Data moves predictably through reliably parts, and the system is locked by unbreakable constraints. This summarizes patterns under the harness engineering category, patterns 10 to 17, and patterns under the intent engineering category, patterns 18 to 23. Let's focus on the design patterns covering groups 5, 6, and 7. Building reliable LLM agents requires shifting from prompt engineering to deterministic system architecture. These three groups govern probabilistic reasoning with engineering rigor. Structuring the agentic core is key. As capabilities grow, monolithic systems become untestable. Group 5. Agent System Engineering Patterns. These patterns govern the design, architecture, testing, and governance of the skill and agent system itself. Not what the agent does with external systems, but how the system the agent operates within is structured. The central tensions in this group are between scale, more agents, more skills, more capability, and coherence. The system remains understandable, testable, and governable as it grows. Pattern 24. Agent Skill Command Triad. Problem. A system that conflates reasoning, who the agent is and how it thinks, knowledge, what the agent knows about a domain, and execution, the specific steps the agent follows for a task, produces components that are simultaneously hard to understand, hard to reuse, and hard to maintain. Solution. Formalize three distinct component types with explicitly different roles and no overlap between them. Pattern 25. Sub-agent context isolation. Every sub-agent delegation uses a precisely scoped context injection. The sub-agent receives a system prompt defining its role for this invocation, explicit paths to the files it should read, a clearly stated task, and a specified output location. It never receives raw session history. Pattern 26. Facade skill. A facade skill contains nothing except a dispatch to the complex pipeline. It is a thin wrapper, 60 to 100 lines, that does exactly three things: validates preconditions, configures the agent invocation, and dispatches. The complexity lives in the agent. The facade lives at the entry point. Pattern 27. JSON state machine with resume. Orchestrator commands maintain a JSON state file tracking, current phase, completed steps, files created, and timestamps. Every invocation checks for an existing state file and offers to resume from the last completed step. Pattern 27. JSON state machine with resume. Explicitly assign model tiers to agent roles based on the capability requirements of each role. Document the decision in the agent definition via the model frontmatter field. Group 6. Composition patterns govern how skills, commands, agents, and plugins are combined into larger systems. The central tension in this group is between independence, each component stands alone, and integration. Components work together as a coherent whole. Strong composition patterns enable both. Pattern 29. File-based message passing. Each step in an orchestrated workflow writes its output to a specific file path declared in its explicit I/O contract. The next step reads that file path at startup. No step passes its output to the next step through the context window. Pattern 30. Plug-in as distribution unit. Bundle related agents, skills, and commands for a single domain into a plugin, a single installable unit with its own manifest, version, and description. Users install plugins, not individual components. The marketplace catalog describes plugins, not components. Pattern 31. Layered template override. Templates resolve through a priority ordered chain. Custom templates override defaults without modifying them. Upstream updates reach uncustomized templates automatically. Group 7. Testing patterns. Testing patterns address the most distinctive challenge in skill development. The test subject is probabilistic. A failing unit test is a deterministic discrepancy between specification and behavior. A failing skill test is an observation that the agent rationalized around a constraint or found an unexpected path through the instructions. The testing methodology must account for the probabilistic nature of the system under test. Pattern 32. TDD for skills. PPLY red-green refactor to skill development. Red. Run the task without the skill. Observe the agent's behavior. Document every rationalization and failure mode. Green. Write the skill to address the observed failures. Refactor. Run the skill. Observe remaining failures. Close new loopholes discovered during green execution. Pattern 33. Tiered testing pyramid. Apply 3 test tiers at different cadences and costs. Tier 1 runs continuously, free, immediate. Tier 2 runs on significant changes, moderate cost, moderate time. Tier 3 runs on release candidates, higher cost, maximum assurance. Pattern 34, pressure scenario. Design test scenarios specifically intended to pressure the skill's constraints. A pressure scenario presents the agent with a situation where violating the skill's rules would be locally reasonable. The skill passes if the constraints hold under pressure. Group 8, distribution patterns. Distribution patterns govern how skills move from development to deployment across multiple platforms, organizations, and update cycles. The central tension in this group is between portability, works everywhere, and platform optimization, uses platform capabilities fully. Validating probabilistic systems requires moving beyond the deterministic paradigm of input to expected output. Group 8 testing adapts deterministic quality assurance to these probabilistic behaviors. The master agentic workflow schematic illustrates the synthesis of rigorous system boundaries. True agentic scaling comes from disciplined data passing and adversarial testing, not just better prompts. Group 8 focuses on distribution patterns. These patterns manage how skills are deployed and updated across diverse platforms. Group 9 covers long-running application patterns. These specifically tackle the challenges of autonomous coding sessions that run for hours and require complex scope management. Pattern 35, platform-agnostic core. The skill library's canonical form is pure Markdown, readable by any LLM on any platform. Platform-specific configuration, file paths, tool names, plugin manifests, lives in per-host adapter directories that are generated from, but do not modify, the canonical source. Pattern 36, dual distribution channels. The same capability is distributed as both a / command for platforms that support it, and as a portable skill for platforms that do not. The capability is implemented once in the canonical form. The distribution channel is a packaging decision. Pattern 37, generation metadata and audit trail. Every generated document includes a standardized footer recording its generation context. The footer is a small, consistent structure appended to every output. Pattern 38, generator evaluator iteration loop. Run a structured loop in which a calibrated external evaluator provides specific critique after each generator pass, and the generator makes an explicit strategic decision about whether to refine the current direction or pivot to a different approach entirely. The loop runs until either a quality threshold is met or the iteration budget is exhausted. Pattern 39, context reset with structured handoff. At a defined trigger point, terminate the current agent session entirely. Prepare a structured handoff artifact that captures the complete necessary state for a new agent to resume the work. Spawn a fresh agent instance with the handoff artifact as its only context. The new agent inherits the task state without inheriting the context window history. Pattern 40, evaluator as conditional investment. Treat the evaluator as a conditional investment rather than a fixed component. The evaluator is worth its cost when the task sits at or beyond the boundary of what the current model can do reliably solo. When the task falls within that boundary, omit the evaluator. Reassess this boundary at each significant model release. Pattern 41, ambitious scope planner. Insert an explicit planner agent before the generator. Give the planner two directives. Expand ambitiously. Turn a one-sentence prompt into a full product spec covering more features than the user explicitly requested. And stay high-level. Specify deliverables and user stories, not technical implementation details. The planner's output is a product spec that the generator builds against. Technical decisions belong to the generator. Pattern 42, harness assumption stress testing. Apply the minimum necessary complexity principle. Start with the simplest harness that could work, and add components only when empirical testing demonstrates they are load-bearing. At each significant model release, identify which components encode assumptions about the previous model's limitations, and test whether those limitations persist. The long-run challenge. Single-pass generation and basic memory models fail at scale. As work length increases, cognitive load degrades output quality exponentially. Surviving hours of autonomous execution requires deliberate, engineered scaffolding. This ends the presentation of 45 design patterns discovered in agentic skills-based systems. If you liked the presentation, please smash both the like and subscribe buttons.